Hello everyone, my name is Victor Odigoma here. You're welcome back to our class once again. And you remember we are looking at circle and its properties. We've done a lot of classes behind, so you can check out on those classes. And the best thing to do is to subscribe so that you can have access to those classes as well. All right, we have started solving practical problems that has to do with circle and its properties. And this is one of them. All right, if you look at this question as we are going to look at it quickly, it says calculate the area of the shaded part. Calculate the area of the shaded part. How can one be able to calculate the area of the shaded part? When I gave my students these questions, they started, every one of us, we were reasoning what could be the possible way to handle it. And then some were saying that we calculate the area of the square, fine. We calculate the area of the circle and subtract it from the area of the square. And then if you look at it, you can also reason that that person is talking in some sense. There's some sense there. And then also calculate the area of this sector and also subtract it. But when you come to in any mathematical problem, especially as it has to do with an examination, we are trying to beat time. Time is very, very important. So we try to see how we can be able to find the best possible way to handle that problem so that we can be able to maintain time in the examination. So now look at my way. Not that I have been able to decipher this before coming here, but I'm trying to show you that this could have been the best way to handle it. If you look at this diagram, you see that there is an empty space here which is unshaded. Now, can it be possible, since we are talking about the shaded part, can it be possible for us to just calculate the area of the square and calculate the area, leave whatever here, and calculate the area of this unshaded part and do a subtraction of both, and then get the remaining, which is the area of, the shaded part? I'm thinking that could be a possible way. Let's look at it quickly. Solution. We say area of, first we take the area of the square. Area of the square, which is of course the area of a square is L squared, one of the lengths squared. If it is a rectangle, you say length times width, but in the square you say length squared because the length is the same measurement as the width. So L squared, which is 14 times 14. Now when you might have the same question my students ask me, where is this 14 coming from? If you look here, there's no 14 here, so where is it coming from? All right. Now, do you see that from here to here is a radius? And you see that from here to here is another radius, of course, that should be also 7 cm. Now, are you seeing that this is equivalent to the one length of this square being 14 cm? So that's where it is coming from. So we will have the length squared to be 14 times 14, which is the area of the square, and that will give us area of the square being 14 times 14 in my calculation here. 14 times 14 times 14 is 196. So this is 196 cm squared. We will come back and say area of the unshaded part. The unshaded part here has a description that is hidden. If you watch here, you will realize that this is a sector with angle 80 degrees. But this side now, which is the bigger sector, the angle will be, of course, area of the unshaded part, which is a sector, is the area of the unshaded part. You say, but area of the sector, that the bigger sector is given by theta over 360 times pi r squared. And here, theta will be 360 minus 80 degrees. 80 degrees. And that is going to give us what? 360 minus 80, 60 away. 300 minus 20, that's 280, 280 degrees. So when we come back here, we are going to have 280 over 360 times 22 over 7. In some exams, they may give you use by 3 points this. Please use whatever they gave you there, times 14 times, no, the radius is 7 times 7 times 7 times 7. So you can see that this will take away this. This 0 will cancel 0 here. 4 into 28 will give us 7. 4 into 36 will give us 9. So I have 7 times 7, which is 49. 10 times 22 all over 9. And by my calculation here, 49 times 22, 49 times 22, that will give us 1078 divided by 9, and we have 119.8 approximately cm squared. You now say therefore area of the shaded part is, in conclusion, is area of square minus area of the unshaded part. So this will give us 196 cm squared minus 119.8 cm squared. So that will give us from my calculation quickly 76.2 cm squared. So this is how we go about this. Okay, I'm sure that this explanation helped us. Please remember, as I tell my students that anytime you're solving a mathematical problem like this, please open your mind, because this, you might finish solving this now, and you've learned this one, and the one you see in the exam will be opposite of this. That is to say, you might see now a circle, a square inscribed inside a circle. So please open your mind and be able to reason fast what you're supposed to do in any given circumstance. Thank you so much for being there. Please like our video, subscribe to the channel so that you can be able to access the previous classes we've had already. And then, okay, and then click on the notification button so that you can be notified. We still have a lot to do. After this sector discussion now, we look at chord and its theorems, and then from there, length of arc. We'll be solving a lot of problems, and from there we'll now delve into the circle theorems. We have so many circle theorems we are going to be discussing with practical examples in them. You cannot afford to miss this class. Thank you so much for being there.